Okay, you're on.
Okay, we're not doing anything. We're doing no. All right, hurry up. Okay, now 2.6, like I said earlier, is going to be a basic part that we're going to do, so we can take tasks before we get too crazy on what we're doing on 2.6, and then we'll come back to it. And 2.6 will be included in the next test as well. Okay? All right, because 2.6 is pretty important in the calculus world. All right, now, who remembers the line, what you call the line that goes through 2 points? And usually it was like the circle when we were talking about geometry. Who remembers what this line was called? What is that line called? No. Line. What's cracking my soul here? Line. What kind of line? S. Yes. Oh, Emma. Okay. This is a secant line. All right. Now, that line PQ is also a secant line. Okay? Now, universally, M is considered the letter for what? Slope. Okay. So, the slope of PQ is what we're going to be looking at. Okay? PQ has the ordered pairs F, F of A, and B, F of B. Okay. So who can tell me how to find my slope of PQ? Come on. Nice. Okay, that's the old standard slope formula. Okay? Now, here's what we want to do. For the purpose of calculus, we want to take Q and we want to move it so it's pretty much on top of P. And now, what do you call this line? Tangent line, that's right. I said for the sake of calculus. I moved point Q. You're not allowed to ask why right now. Just do it. Okay? We'll explain it as we go through. Remember I said be patient. I haven't seen too much patience yet. Okay. So the PQ is now a tangent line because P and Q are like basically on top of each other. I moved Q all the way down here and I created a tangent line. Now, what you don't know is that a tangent line is very important in calculus. Like, really important, okay? So here's what I did. I let Q approach, get the language, P along the curve by letting X approach A. You see a limit in your future here. Yes, okay. So the tangent line at the point A, F of A now, which is now simultaneous with P and Q are the same point now, is this limit equation. Okay? All right, now that is the reason we did that, so we can now talk about a tangent line. And again, a tangent line is important in the calculus world. Okay? You will see that as we go on, but that's why we wanted to do that. Now, if you, I have a thing that I don't know if sound really wasn't working very good. You're gonna look at it here, hopefully. Okay, shh, girls, you're being very rude. I gotta stay. When you're talking, all right, so here is the point being moved around. The secant is turning into the, look, it's moving, and basically the blue and the now becomes a tangent line, okay? If you look here, I can do it again. If you look here, your values are changing. Your A was changing. wasn't changing, your b was changing, and b minus a, of course, is changing because that's the distance between the two. It's changing to nothing, pretty much. So that's where the limit comes in, okay? Is that we're approaching 0 when we approach Q and P approach each other, okay? So you're going to have to remember that, but in my years, that's the least of your worries, is remembering that formula, okay? So this is the slope of, not the secant line anymore, but which line? Right, slope of tangent line, okay? So you're going to use that formula. A is going to be at a specific value, okay, whatever that A is. We're not going to have to deal with A. We're going to deal with a letter, okay? And f of x will be a specific, this looks like it's a quadratic, but it's not necessarily always going to be a quadratic. Okay, so we are going to talk about, find the slope, which is using this formula, of the tangent line to the parabola y equals x squared at the point 1, 1. Okay? All right, so tell me what limit A is. Who can tell me what A is? Where A came from in my, where did A come from? That was my original point, and that's where the tangent is. The x value, that's right. So this is A. Okay, what's the other one? F of A, good job. Okay, that's an ordered pair. It's your A, F of A. That's the point at which you are having the tangent. Remember that on your parabola, which everybody knows that y equals x squared, like that, 1, 1 is about right here, right? Your tangent line, go ahead and draw your tangent line at 1, 1. Right. This should be down here, but yeah, we know it. Okay. You're not that weird about it, right? Okay, what does your tangent line look like? Let's see. Let's look at Lizzie's tangent line. Let's see what it looks like. Oh, it's beautiful. Okay? Now, it sort of looks like it smashes the whole side of the parabola. I know it's very difficult not to do that. But the whole idea behind a tangent is that you're grabbing that one point, that 1, 1, and making everything else not touch it. But I know visually it's very hard to do, but good job. Okay. Let's go back to this. I'll draw one, my tangent line. Okay. There you go. All right, so there's your tangent line. We are trying to find the slope of it. I know by looking at this that it's going to have what kind of a slope? Positive. Very good. That's all I really know, just because I don't have any grid set up or anything. Okay, so here we go. We're approaching 1 then, because A is 1. Oh boy, what's f of x? Yeah. No, it's supposed to be going through 1, 1. Okay. Yeah. Find the slope of the tangent line to the parabola at the point 1, 1. Yeah, you have to start at 1, 1. It has to go through 1, 1. Yeah. Yes, that's it. Okay. Right? All right, Kelsey, what's f of x? Well, it's in there. Look for it. It's in the problem. F of x. Sounds like a function to me, darling. Ah, you got it. There's f of x. So I'm going to put x squared right there, because that's f of x. All right? I think we already discussed f of a, didn't we, Emily? What is it? 1. Okay. And x minus, we already discussed a, and that's 1. Now, this is a limit that you've done before, I do believe. But let's just do it like we haven't. Limit, x approaches 1. Oh, I can't plug in because I'll make a 0 in the denominator. So what should I do? Can't plug in. Can't cancel out because you got to cancel factors. Hint? That was a hint. All right, and when you say do that, what's the real language that we're using here? What's the word that you said do that? What are we doing here? We're getting ready to cancel factoring. Okay, because then we can cancel a factor of x minus 1, and we can plug in because now 1 is no longer a problem. And what is our limit? 2. So what is our slope? 2. The slope of this is 2 over 1. Okay? Now this visually is exactly that, just a visual. But don't forget what you're doing. Okay. So everybody get their calculators out. And clear out anything that you have from before. And put in x squared. Okay, we're going to start with the standard viewing window. I know you know what that looks like, but we're going to do a little experiment here. Anyway, demonstration, that's okay. Okay, I want you to hit, everybody ready? Hit the trace button. And mine is right where I want it to be. Okay? Actually, I want it to be at 1. So I'm going to hit this. So I'm close to 1. That's 0.9. Okay, just close because I'm going to zoom in. All right? Y'all know how to zoom in? Hit the zoom. And I want to zero in, so zoom in, number 2. Come on. All right, now it's not doing anything because you have to hit please. That's your please button right there. Okay. Hit enter. That's please. Give me an answer. Okay. Now, it's a little bit zoomed. I want to do it again. I'm staying the same point. So, zoom in again. Press enter. Press enter. Okay. Now, you lost the axes. That's okay. They disappeared. I'll do it one more time. Zoom. Just trust me. Y'all are so distrustful. I tell you what. Where you were should have been around 1-1. Okay, now, Caitlin, say that again. Okay. So if I zoom in close enough, magnifying that little part, it's going to look like a straight line. Okay, so my point in doing that was this statement down here. This statement says that this right here is also known as the slope of the curve. So the slope of the curve and the slope of the tangent line are going to be one and the same because if you zoom out long enough, or close enough, you're going to get a, whatever. You're going to get a line, okay? So this and tangent line slope are the same thing. So when they ask you for that, you're going to use the same formula, okay? So that's why I had you do that. It's also called linearization. If you're ever looking like, what is she talking about? That's linearization, making everything linear by zooming in close enough. Okay. Now, you all have questions. We're going to continue to use this function, this formula. Can we keep going? Good? All right, here we go. Okay, now, here's the thing, is that we're going to change the language a little bit. That's what we're going to do. And I know that it's like, why did you? Well, because we had to go with the starting point of where you were. This starting point was this secant line. So that's why we used A and B. Then we said, all right, let's use A and A plus H. Okay? H is the distance between what used to be A and B. It's now called H. Okay, so Q If we're not using b and f of b, then those two ordered pairs need to be changed to, what's the x value on the q? A plus h, good. And what's the f value? Awesome, f of a plus h, very good. Okay, so we're just changing the language. H is the distance between the 2 points. It used to be the, okay, it used to be A and B, but we changed it to be A and A plus H, okay? All right, so who can tell me the slope of that secant line PQ again, using the new language? Emma gave it to us last time. Here's the secant line. It's the rise over run. Y over X. Go ahead, Holly.
F of H minus
F of A plus H, you mean?
Yeah.
Okay.
minus F of A.
Good. Over
H. Or A plus H.
minus H. Which, oh, sorry.
No, it's minus A.
Yeah, you're right. Which is the same as. Okay. So if they cancel each other, we have this. Okay. So all we're doing is changing the language. Now equation 2, the other one is equation 1, says the slope of the tangent line is this one. Okay. Check it out. With your limit knowledge, this should make sense. As we made this H. Remember what we did? We moved this guy over so that H was close to nothing. That's what that means. A distance was close to nothing, and we created a tangent line. Okay? So we did the same thing we did on the last slide, except we are changing our language. Okay, so we're going to find the slope of the tangent line to the hyperbola y equals 3 over x. All right. The formula that we're going to use is equation 2. There's a delay again. Being very patient now. I appreciate that. Okay, you remember what 1 over x looks like? Yes, so 3 over x will just be slightly taller. It goes like this. 3 over x just multiply by 3. It looks very similar. Okay, so just as a visual, that's all we want. Okay, now, please note we don't know where the tangent line is right at the moment. Okay, so we are going to maybe talk about this tangent line, or maybe we're going to talk about this tangent line, or we got this one. You know, we got a tangent line anywhere we want to grab one, but we're not doing it. We're just going to find the generic slope. And you'll see what I mean in a minute. That doesn't make sense. Okay, so let's identify what's what here. We need f of a. I guess we'll start with, just to be clear, f of x. What's f of x? 3 over x. Okay, good job. What's f of a? Come on, that means put a in the f of x function. Kathleen, help her out. Yeah. It's just kind of a, what? Why are you doing that? That's, we're trying to get the right language to put in here. All right, f of a plus h. Where? Is in your f function.
3 over A plus H.
Nice. Okay, do we need anything else for this formula? I don't believe so. All right, we're ready. Limit.
H equals 0.
H is H. Okay. F of A plus H, 3 over A plus H, minus F of A, 3 over A. Okay, it kind of looks like one we might have done today. I'm going to move it over so I can tap it. Ooh, great. Okay, how do I simplify? It would be nice if I can't just plug in 0 because I'll make my denominator 0. What shall we do, Miss Maggie? Multiply by what? Say again. A plus H and A on the top and the bottom, which remember is just a well-designed 1. When you multiply by 1, it doesn't change. Okay, you have one like that on the homework problem, except if it was like 2 plus x and 2. Remember that? Okay. All right. Here we go. We're gonna distribute. I'm gonna write the bottom because sometimes I forget. All right. What is the top? We're distributing that A plus H times A times 3 over A plus H. After, what do we get when we multiply this times that? Very good. The A plus H's are going to cancel. Nice. Okay. And what do we get when we're going to do 3 over A times A plus H? Jenna?
3A plus H.
Okay, I just made a mistake. Tell me what I did.
You should have left the A plus H.
No, that was good that she multiplied that out. But what have I done wrong?
You wouldn't put H.
Okay, you all are looking at, I'm going to go back to Jenna's too advanced for us. Just kidding. All right. Okay. That's what most of you all would do, right? Okay, now what's the next step in your algebra process? Distribute. Okay.
How did you distribute to make it minus?
That's what I had. So what should it be, Hannah?
Now should it be 3A minus 3 minus?
Yes, ma'am. Okay, because you are distributing a -3 there. That's the #1 mistake. That would be the first thing when you're like, oh, I didn't get it right. That's where I'm going to look, because that is a mistake. Okay. What now?
A's cancel.
A's cancel. All right. We're making progress here. Now, all this time, I'm not multiplying the bottom out. Why not? Right. Because I want to cancel factors, so it's a factor. There's no point in multiplying it out. Now what? Still have this stupid 0 problem. Can I finally get rid of this problem? Yes, they're both factors. Done. All right. That's my whole goal in my limits is to get rid of the problem. All right. So now I can plug in. What am I going to plug in? 0 for H. All right, so -3, A times A plus 0. What is that? -3 over A squared. Remember I told you it's going to be generic because we don't know where we are on that hyperbola. That's your limit. That's your slope. The generic slope. We can apply it to any A we want to. Okay? Does anybody have a question about any of the algebra? The limit is -3A squared over A squared. Yes. So the limit. Remember, the slope is this limit. The slope is this limit. So, yes. Yes, Christina. Well, looky here. That's what we're going to do next. You're so smart. All right. Now, let A equals 1 for the previous example. Remember, the slope of that tangent line was generically from the last page negative 3 over a squared. Okay, well, if a is 1, okay, we should be able to plug in a equals 1, and what do we get? Negative 3. Okay, so the slope of the tangent line is negative 3 at this point 1 something. I guess it's 1, 3. Okay? I put in 1 because I wanted that to show up. All right, now we have the slope. We have an ordered pair. We should be able to find the equation, right? Yes, Holly?
Would it just be f of x or y equals negative 3x?
No, because that would assume we're going through 0, 0. We have a b.
Oh, whatever.
Okay, this is the formula that we like to use because it's very direct. This is the point slope formula. Notice I put my slope in, and these are variables, but this is your point. This is your x point, value of your point. This is your y value of your point. So what are those x and y values? X is 1, y is 3. I'm done. Okay? I want you to get your calculators out again. Okay? Did I lose anybody? Point slope form. This is it. It's a lot quicker than the b, y intercept. So you gotta find b and then you put it back in. And then you're used to that, but you can get used to that too. It's quick. No. It'd only be plus if you're putting it in negative.
I thought it did.
No. Okay, so here we go. Go back to standard window. We're putting in the 3 over x. 3 over x, that's my hyperbola. And I'm also going to put in this tangent line. Okay, now I have to start with y equals more of a tangent line, so I'm just going to pull this 3 around. So now it's 3 plus negative 3. I'm just being lazy. I don't want to fix it. I just want to get to graph real quickly. Everybody see what I did? Just pull this 3 around, and then that's y equals. All right, now if it doesn't look like a tangent line, you either, oops, I forgot I did fix my standard window. My window was real crazy from that zooming in, remember?
Why did you graph the 3 over x as well? Just because that's the source?
No, that's my equation. And here comes my tangent line right there. Does that look like it's supposed to look?
No, mine is.
Well, you did it wrong
It
then.
gets 2 up and then it gives me an error. Wait,
There is no third. There's just 1. It's just 2. So what did we graph?
oh, I'm missing this.
You graphed the equation, which is the blue, and then you graphed this tangent line. If it doesn't look like a tangent line, then you either put it in wrong or you found it in wrong. That negative sign probably is subtraction. You can't put it like so every time you contact here,
oh, we got it.
what's mine? Yeah. Pause. Which one? We have. We really finished that. I thought we. Okay. So we this problem, remember we were doing it off of what we did in the page before that. So we were applying, like Christine said, A equals 1 here, so we applied it. Now, it would have been faster to use this other formula since we knew A. Okay, let's just do it real quick here. This was y equals 3 over x, m equals limits. X approaching, remember we were approaching 1. Okay, of f of x minus 3 over x minus 3. Okay, we should get the same thing. What did we get before for the slope? The slope was -3. Okay, so I'm just doing a different route here, just going a different route. What should we multiply by? X, good job. X over x. Okay. So what do we get? 3 minus 3x over x minus 3. I know I'm doing this fast because I want to make sure we get through. I'm going to take a 3 out. I'm going to get 1 minus x. Wait, what am I doing? I don't even need to do this, do I? I could have just substituted from the beginning. Gosh sakes. Yep. Okay. I can plug in 1. 1 minus 3. 1 minus, got it? What's 3 minus 3? Oh, for gosh sakes. What the heck is going on? Oh. I'm so sorry. I'm trying to hurry and I'm making mistakes here. This is x minus 1. So we were right to do that. I'm using the other formula to show you that it would have been quicker. There's your -3. Okay? Well, it just depends. Yes, I'm glad you asked. Okay? Because you have 2 formulas and your job is to decide which one to use. Okay? So you got this one. And by the way, there was an A here, an A here, and an A here from the other one I gave you, so it just doesn't matter. X plus H, A plus H, same idea. Okay? And they have this. Now, the name of what we're doing is the derivative. You tell anybody that asks you what you're doing in calculus, and you say derivatives, they'll be like, okay. That's a big thing. It's like half of calc, derivatives. Okay? And its name, another name is called F prime. F prime. Okay? Now you can't call it what you want. Its name is F prime. If I called Caitlin, she would correct me. Okay? And she does. And she does. Because that's not her name. So you can call F prime F, because they're 2 different things. So be careful. Okay. So what we have been doing, let me just show you here. We have found the slope of the tangent line. We have found the slope of the curve. We have found now is the derivative. They're one and the same. Okay? All right. So when it asks to find the derivative of f of x, it's also, derivative is also known as what? Slope of the tangent line, like we did before. Okay, we have 2 choices of equations. What are we going to use for this one? First one, which would be definition 4, or definition 5. Okay. What do you think, Kenny?
I'm going to go 5, just for fun.
Actually, we're going to use 4. What is A is a specific specific X, and we don't have that. And if you use that, you won't be able to do that one. Okay? So there's a clear choice, but you'll use this one if you have a specific A. It's okay. And I should have told you that. All right, yes. Nothing. They're same thing. So it's like your name is Megan, your name is also Megan Hoft. What's your middle name? Your also name is Megan Ryder Hoft. Ryder, whatever. Ryder. It's fun. Okay, anyway.
Megan Ryder.
Those are all your names, right? Derivative is its name, f prime is its name, slope of the tangent is its name. So we're going to be asked to do the same thing with and call something else. Okay? Yes. The derivative of fx is also f prime. Okay? Now, am I going to find f prime of x? I think some of the problems, they'll call you f prime of a. Okay, so I'm going to use definition 4. All right? And don't do this, ladies. You see what I did? Blah, blah, blah. Yeah, because you're going to do it. The derivative, then f of x equals this is not the derivative. The derivative, it has a different name. Don't call it f of x. Don't continue f of x and say that's now f prime. Okay, we start f prime. I know it seems silly, but it's going to be very important. Okay, so here we go. I guess we need we got f of x. That's 2x squared plus x. What's f of x plus h? Lizzie? Good. Okay. Oopsie. I'm going to go ahead and multiply this out. What's x plus h squared? Squared plus, what is it, Claire?
Plus hx plus
2hx then plus h squared.
yeah.
Plus x plus h. Again, that would be one of those things that would be helpful if you could do that quickly. 2xh plus h squared plus x plus h.
It's like all connected.
That's all, yeah. That's
And let's say plus 2h plus h squared. Plus x plus h.
yes, that's right here.
I can't. Oh, no, this is
Put your lights on.
He wasn't asking.
You do it now.
Wheelchair.
You could.
Who says that, Miss Becker?
All right, I'm going over here so I don't run out of room. Don't lose your limit. All right, f of x plus h is all that business. I'm going to go ahead and distribute my 2. That'll save me a step later on. Okay. Minus, I'm right here. This is this. What's next? F of x, which is, okay, I just made a mistake. What is it? Distribute the negative.
Okay, why did you just add that on?
Because it's on the formula. This is, okay, I'm just using the formula. You can't get lost in all the yuck. Okay, now let's start simplifying. We're trying to get rid of our h. That's our bottom line because then we can plug in 0 for h. Okay, so what can I cancel out? Okay, what else? All right. 4xh plus 2h squared plus h is left. Did I miss anything? Okay.
No, you can.
Okay. My h is still there. How do I divide it out? Factor out the h from the top. That's right. We cancel factors, ladies. So 4x plus 2, what? H plus 1. Now they cancel. Oh, yes. This is one problem. I'm just going to rewrite this. Don't really have to do this stuff. And remember now, h equals 1, 0. So what do we get?
4x plus 1.
That's the derivative. That's f prime. That's whatever you want to call it. Okay? Yes. That would also be the slope of the tangent line if we were looking for it. Okay?
So it's the derivative and limit and the slope?
Yep. And it would also be the slope of the curve if we wanted it. So we're going to call all of those. The derivative is like the vocabulary. This is the name of it. This is just other things we're going to refer to it as well. Okay, I think I am finished. We've already did one like that. Let's I sent a handout